Okay, lesson 11-4, normal distributions. Remember, normal distributions, the bell curve. And some of the things you're going to run into in this lesson are percentiles, standard normal distribution, and a z-score. And what we're really trying to answer here is how can you use this normal distribution to explain where data falls within a population, so for a whole population. And this is probably the most important slide, I would say, of all of them, and that is it's a normal distribution. So this mu right here is what the symbol they use for the mean, and this sigma, lowercase sigma, looks sort of like that. If you go one standard deviation, so that's what this is showing right here, one standard deviation out, one on each side, to the left one and to the right one, you'll catch 68% of your data. If you go out 2 standard deviations on each side, you're going to have, so this is showing 2 standard deviations below, 2 above. This is going to have 95% of your data. If you go out 3, you see your 99.7%. And when you go out, you see 4 labeled on there. I believe that that is the most that you go on each side to hit all 100%. All right, so here's a formula that you can use, a z, and z is just how many standard deviations you are. So like this one right here, looks like it might be like a negative 1.5, 1.5 standard deviations below the mean in the middle. And you calculate that by whatever piece of data you have, your number minus, minus your mean and divide by your standard deviation. That'll give you your z. So let's, if I have a number that's 70, but the mean is at 50, and each standard deviation is 10, so 70 minus 50, I'm 20 points above, and each standard deviation is 10. So I'm 2 standard deviations above the mean. But they won't always come out to this nice even number. So that's why we have this z-score thing that they refer to. So what if that had been a 75? So 75 minus 50 over the 10, and the same problem. I've got 25 over 10, so I'd be 2.5 standard deviations above the mean. So if I go up here, there's 2.5 right in here somewhere. And if they ask you for the percentile, so remember, we said there was in 2 standard deviations, that's 95%. And we said if you go out 3 on each side, that was going to be 99.7% of the data. So how much is between here, if you're talking about in between there? And then it's not a linear relationship because you notice this is a curve. So it doesn't have a constant rate of change. And that's where a lot of times you're going to use a table, or you're going to have some other electronic way to look up and convert this 2.5 standard deviations above the mean into a percent. So you know that at 2, we have 99.5. So there's between above and below, there's 5.5%. So there's 2.5% above and 2.5% below. So if you wanted to know, like, for example, just from the 2, there's 97.5%. So this point right here that we were talking about, 2.5, it's higher than that. Or there's even less than that that's above. So just a couple of things to keep in mind there. This is that same picture we had before. It's called the empirical rule. These percents are rounded off. They're not exactly these amounts, but these are some pretty good estimates. So if they gave you a problem like this, where they talk about in 1817, they took the chest circumference of some Scottish men. They they ranged. Their range was 33 to 48. The mean, the middle number right there, you can see is 40, and a standard deviation was 2. So between 38 and 42, that was about 67% of the data. From 36 up to 44, that's 95% of our data. Okay, so if you were to draw a picture, that's what it would look like. You draw your bell curve, put your mean 40 in the middle, get about 2/3 of the data between here, and label your 38 and 42, 2 up and 2 below as you go. All right. So what would you expect for chest measurements to be for the 2.5% smallest? So down here, remember from here to here was 95. So that left 2.5 above that and 2.5 below. So 36, there would only be 2.5% below them. If you were talking about the 44, there would be 97.5% below there. Take a look at one like this ACT. So I like these problems to draw a picture. So imagine that's a normal curve. The mean 508, middle, and then standard deviation of 121. So if we go out here, you know, this first 2/3, 121 below there, 121 above there. Let's see, I can go above 121 would be 629, and then 121. 121 below that. $387. And then if you go another 121 below that, so when they go out 2 standard deviations, remember that's going to give us 95% of our data between those two. So take out another 121 off from there, it'd be 266. If you go 121 up from here, it would be 750. So when they ask this question right here, what percent's between these two, that would be my 95%. Then it says 266 to 629. So now this time they're asking from here to there. Well, remember the 629, what percent was above there? There's different ways to get your answer here, but I'm going to go this route. So remember this, in this blue right here was 68%. So that means there's 32. So there's 16% above this. And then the 266, remember that was 95%. So there was only 2.5% down here. So it's everything but these two. So when they're asking for this in here, take the 100, take out the 16, take out this 2.5 over here, and whatever's left would be your percent between there. So some form that, you know, there's other ways again that you can get that solution. Now, sometimes they'll just give you this formula to use. Whatever your number is, minus the mean, that's how much you are above or below the mean. And they'll a lot of times write it like this. X is your number. This mu, Greek letter mu, is the mean of your data. And then subtract the standard deviation. That tells you how many standard deviations you are above or below the mean, and they call that the z-score. It's oftentimes a decimal. So if you go back to this problem that we're given right up here, and you can compare these then to see who did better comparatively to the situation. Because in this problem, we have Ella and Alicia, one's doing the SAT, one's doing the ACT. So if we take a look here, we've got Ella, a 1380 on the SAT, and the SAT mean is 1,000. So if you take Ella and you take her 1380, subtract the mean, that means she did 380 better than the mean, but the range, one standard deviation on the SAT is 200. And so if you divide that out, in terms of standard deviations, how did she do? Well, if you take the 380 divided by 200, she did 1.9 standard deviations better than the average. So then we'll go to the next one. So let's say we're taking a look here. Again, that was for Ella. So let's say we're taking a look here now, this time at Alicia, and she had a 32 on the ACT, and the ACT mean is a 21, and the standard deviation is a 5. So let's see how those work out. So her 32 minus the mean or average was a 21. So she did 11 points better than the average, but then what's one standard deviation there is a 5. And so if you divide by the 5 here, that's a 2.2. So where it doesn't look like she really did better on the test, that was again for Alicia, compared to the other one was for Ella. So in this case, she would have done much better. And that's a summary of how you can use your z-scores percentiles when doing those problems.